how close is what is your predictor to like truth, right? And so, you know, you can have things where you want, you know, looking at this is all being translated a little bit, but you can say like, how close am I to the truth? And you can say like, maybe in this example, the truth is the floor down here. And so obviously what we want to do is be able to take our function that we're learning, or like our system that's doing the learning, and force him to move closer to the truth. Okay? So there are problems that you can do where, say you have like a curve, it doesn't look all nice. It's not like a bowl like this, you know, with just like one bottom or something. But say it's like some kind of problem like this where you have local places where you could go here and you'd be like, hey, as far as I can see, this is the best I'm going to do. But if you just went a little farther to your right, there's a much better spot over to the side. Right? So how do you deal with these things? You can use algorithms that use first order methods like gradient descent, where essentially it just says like which direction is down, and I'm just going to go that direction, right? And so like this guy, it makes it really easy, but this guy, he can get trapped here because he goes, there is no down from the green spot, right? So, but then there's second order methods, and here's an idea of gradient descent. We just kind of like approach the minimum. But second order methods, which is you take into account like the idea of like the best way to describe it is how steep is the bowl at certain spots, right? Can I take bigger jumps in this space? Can I be like, I'm going down really fast, so like I might as well just like leap off into oblivion because I'll probably land someplace further down. But then when it starts to taper off, so like if I'm here, I can be like, whoa, jump way over here. But if I'm here, I want to take little tiny steps. And so what second order methods will tell you is like, how fast is like the curve changing? And so you can know based on the second order or the second derivative of these kinds of curves, you know, whether or not you should slow down the acceleration. Is that about right-ish? Yeah. So anyway, there's another picture of something that's a little more complicated, more complicated curve. Okay, so say you want to design your own machine learning algorithm. Let's go through the steps. First is you go to AI's class. All right, so first we're going to pick a type. You know, are we going to do unsupervised or supervised? That's going to depend on your data, right? I don't have any labels, so I'm stuck in unsupervised land. We're going to pick an algorithm. You know, we've gone over a whole bunch of those. You know, are we going to we're going to transform the domain? So like, you know, like we're given, you know, pictures of things, right? That's what we got. And so we're going to have to do something to it to make it so it can work in our algorithm. So I'm going to turn everything. I'm going to use the colors of the image. A feature. We're going to pick a training technique. You can do it like online or offline, you know, batch learning. You know, are we going to be getting like more and more information as this system is running, or do we just have like all the information in the world?